Context engineering sounds as exciting as reading a book on spreadsheets. We'd all much rather be watching that cat play an accordion. But here's the cold hard truth. Ignoring this is why your AI currently has the situational awareness of a caffeinated toddler. It's the difference between a system that actually works and one that just confidently lies to your face. In this video, we're going to look at context engineering, why it's the most important thing for building any system, and I'll give you some free tools to make it easier than it's ever been for your next build to get off the ground. So let's dive in. Okay guys, first off we need to set the scene. So for this entire thing, we're going to be using my sales and lead gen platform that I built using agentic AI. If you haven't seen the build, you can check it on the screen now. But otherwise, we're going to be going through it step by step so I can show you how I apply context engineering to everything that I build or everything that we do. And it will also help nail the concepts home to you. So let's go over my system at a high level. Now, what it does is we have a LinkedIn URL. It goes into a system that it scrapes from Apollo. And then ultimately, it needs to build me 3 personalized DM messages that automatically get pushed to LinkedIn and sent to a bunch of leads. That's it in a nutshell. It's really simple. So the input is Apollo leads, Google Sheets, and it runs on a CROD schedule at 8 a.m. every single day. Then the AI pipeline is that it will scrape these people, then it researches them, it analyzes them, and it generates me the messages. Then I have a human gate, which is just me approving or rejecting something because I don't want to send messages to people without having seen them first. And then finally, the output section is the 3 DM sequence, which goes to HeyReach, and then HeyReach does the further automation. So this system runs every single morning, and it's built entirely based off of context engineering. I didn't have to code any of this stuff myself. I just gave the agent enough context around exactly what I wanted. And that's why this is so fundamental. So let's get into this with a practical example. Let's say that you brought in an amnesiac genius intern into your company. His IQ is 160, and he's here to fix all of your problems. So you bring him in, you throw him in a room, and you tell him, there's 1,000 unlabeled files, I want you to fix our budget. Now, realistically, the intern's going to do something in your company, but it's probably not going to be the thing that you want because he can't possibly know what good looks like for your business. You haven't told him anything. All you did was give him 1,000 unlabeled files. But then equally, you've given him no working memory because remember, he's an amnesiac. So you've given him no way for him to remember what he did 5 minutes ago or 10 minutes ago. So those are the things that we want to look at fixing with context engineering. Because otherwise, all you're going to end up with is really confident hallucinations, which are no use to you, or you end up with the AI slop that you see running rampant in blogs and posts on LinkedIn and stuff like that. Those are people who haven't bothered giving the personal context of who they are to make their personal brand sharper. They just put something out there and say, write me a blog. And it will go and do that. It will write you a blog on cybersecurity, but it's going to be slop. And that's why context is so important, because we can make it personalized. We can make it nuanced to who we are. And then finally, just to nail this point home, is a lot of people think that you need to use the best model in order to get something done, but that's not true at all. Most of the models that we have, they're really good at getting what we need. The problem is that we don't feed it this context that we need. So the gap is what causes the failure. It's not that the agents aren't smart enough. And that's what we aim to fix with context engineering. So that brings us to our solution, where context engineering is providing the system the exact right amount of information that it needs in order for it to do the thing that it wants to do. So you don't just throw that into the whole system and look at it as this massive picture. Like most things in life, we want to chunk them and we want to break them down into specific steps, as you'll soon see. So if we give it a more anchored definition, context engineering is designing the environment around an AI so that the genius can actually perform in the way that it's meant to. Instead of hoping that the model figures things out, you guarantee it has exactly what it needs to do the exact thing that you want every single time. And you can see here how it solves the amnesiac genius problem. So instead of being dumped in a room with 1,000 unlabeled files, we now have labeled folders for each specific task. Instead of saying fix the budget, which is a vague instruction, we have a clear checklist. Step 1, do this. Step 2, do that. Instead of having no idea what happened before, you can give it briefing notes, or in this case, it might be context memory or RAG if your system is larger and you need that sort of thing. The point is you want to give it knowledge and memory so that it can check what it did in previous steps. And it doesn't have to be something complex like RAG. It could even just be the output from a previous input, as you'll soon find out. And then finally, what you end up with, instead of having something brilliant but unpredictable, you have something brilliant and reliable. And that's what we want in business or any system. You want this deterministic reliability that gives us the exact result every single time we use it. And that is why context engineering is the bridge that you desperately need in everything that you're building. So it's not about making the AI smarter here. It's about designing an environment where the genius can actually perform. Cool. So now you might be asking yourself, what's the difference between prompt engineering and context engineering? And they're two very different disciplines, but they build off of one another. So prompt engineering is the art of phrasing a single request to get the best performance from any AI interaction that you have. So for instance, the focus could be word choice, the structure, and the examples. Your scope is definitely going to be one prompt and one response. And the goal here is better output from this specific call that we're doing right now. With context engineering, as you now know, it's designing the entire system so every step has exactly what it needs. And the focus here is going to be the workflows, the state of the system, and the information architecture. And the scope of it is multi-step coordinated processes. And the goal here is to build that reliable, repeatable system. And you can do this with a pretty simple formula. So if any of these are 0, your system fails. Reliability, which is just output quality, equals the process times the context plus the state. So the process in this case is what to do. The specific steps of each task, and this could be a workflow broken up into the specific steps. The context is how to do it well. So the knowledge each step needs. The ICP, the voice rules, the examples, things like that, the constraints that a system might have, different context for different steps. And then finally you have the state. So what has happened so far? And this could be the memory between the steps. It could be simple, like the output from step 1 goes into step 2. It doesn't need to be something complex like RAG. Of course, that's part of it, but it doesn't always need to be that. It's just something that the system needs in order to do the next thing that it needs to do without completely making up a bunch of stuff that you don't really want. And we're going to cover these things in the next 6 slides based on the exact system that I built. So the first step is arguably the most important, and this is defining the task. What does done look like? The definition of done. If you can't show me 3 perfect outputs, you haven't defined the task. And you can think about this in the real world as well. Say you tell someone to go into the kitchen and make you a sandwich. If you don't tell them what kind of sandwich you want or what the perfect sandwich looks like, they might come back with something that you hate, in which case you would tell them that they're useless. So the problem is on you, not the system, like we've already been discussing. So you want to start with your golden examples. Before you write any code or prompts, collect 3 examples of the perfect output. This is going to be your North Star. Then you want to define the success criteria. So what makes this output good? Is it the character limits, the required sections? Is it the tone that we wrote it in? Is it the way we reached out to people that makes it perfect? These things need to be included because the more information the system has, the better it can be. And then finally, you also need to define your failure criteria, because just because something looks good, you need to understand what bad looks like. If you can give that, I don't ever want to see this, this, and this, you're going to get a much more accurate system because it wouldn't even bother looking at those avenues. So if we look at the example of my golden output for my lead research, I fed it 3 versions of what I wanted. So DM1 is a pattern interrupt, and we say something simple like, hey Sarah, noticed you're hiring AI and ops roles and talking about AI strategy. The first fight is usually figuring out where to point AI so it's not another science project burning budget. Made a 5-question AI readiness snapshot that maps that. Want it? So you can see here, I defined a few successful criteria. Under 300 characters, references real evidence from the profile, no meeting asking DM1 because that will destroy you on LinkedIn, and we sound like a peer, not a salesperson. I don't want to be salesy at all in my DMs. So it's all tailored around that, and it's all built, as you'll soon find out, off of real information. So the failure criteria claims AI usage without evidence, uses unlock potential or synergy, and those corporate buzzwords that people throw around, asks for meeting immediately, that would kill you straight away, and generic compliment that fits anyone. I'm sure you've seen that kind of stuff online where people will put 2 pieces of your profile together. Either you went to high school and did this thing and they're like, yeah, let's put this together as an opening line, that's a compliment, and then they go straight into sales. That's why you lose immediately. So you don't want that kind of stuff. The point here is if you have domain expertise, you're already ahead of other people because your definition of good is going to be way better than those people because they don't know what good looks like. So because I've been consulting for the last 10 years, I know a lot about sales psychology and that sort of thing. And for me, this works really well. So I knew the definition of done, but don't worry, if you aren't an expert, I'll still give you some cheat codes to get there anyway. Point being, this is what you want to start with. I would put this on a canvas and I would say, this is what I want my DM to look like. Every single one that we reach out to people, how do we get there? And that's what we do in the next step. We map our process. We break it down by reverse engineering from good. So a complex goal is just a bunch of tasks in a trench coat. It's the same thing in life. If you think, start a business, I have no idea how to do that. Cool, okay. Do I know how to set up a domain? Yes. Do I know how to read a book that would teach me sales? Yes. Do I know how to do this? Yes. Point being is that if you chunk things down, they become far simpler, and that big scary thing is easier. Same thing when you're building a system. If you chunk it down, into its smallest steps and give the context that it needs, the system is going to be much better built because you've solved each problem specifically in the best possible way. So you need to slice it until it's obvious. Keep breaking down until each step is almost impossible to get wrong. If it needs judgment and creativity and research, it's probably too big, so you'd want to go one step smaller. So the 5-minute intern test is, could a smart intern complete this step in 5 minutes with clear instructions? If not, you need to check it again. Think about it when you're starting your first day at a new job. This happens all the time. Me as a consultant, I'll go to a site for 6 months and I'll be like, okay, cool. I'm here to check over your security architecture, where are your processes, where are your standard operating procedures, stuff like that. And most of the time they don't have any. They just expect you to understand, yeah, we put everything in Git. Okay, how do I get there? Where is the URL? Stuff like that. It's not documented. So you can see how that's problematic, because obviously I would go in there and be like, I don't know where any of this stuff is. So if your system is like that and you think, oh, I've defined everything clearly, ask yourself, do I know exactly what's happening in this step? And if I handed this to the person next to me, would they be able to understand what's happening? That's a really good way to understand if you've given it enough context within that step. And then finally, you need to define what goes in and out of this step. So each step, what goes into this thing, what comes out, the output of step 1 becomes the input of step 2, and so on and so forth. So let's look at it from my example here. So the worst thing you could do is have one giant task. Take this LinkedIn URL and write me personalized DMs. You can see why it fails, because AI has to figure out how to get the profile, decide what's relevant, research the company, understand your definition of personalized because you haven't given it that information, write in your voice, and follow character limits that it doesn't know. So a whole bunch of stuff in one giant task is the worst approach. So if we break it up into tiny obvious steps, you can see why it becomes simpler. Step 1, scrape. Input, LinkedIn URL. Output, name, title, company, and posts, because that gives us the information that we need from LinkedIn. Step 2, research the company name and the domain, and maybe even the person if we looked at a person's profile. And the size, the funding, the news, the tech stack, because all of these things give us the output that we need for the next step, which is classifying it. So we have the profile and we have the ICP rules, and then we define an archetype, which in this case is literally just giving them a label. And we do it based on the signals here. So if they have funding, or if they post about any news about, we're expanding in AI, or we're looking at this opportunity within AI, we know that they have declared change as their label. And with declared change, that gives us the output that we need to write them the perfect hook. So we take their profile, we take their research, and we take their archetypal label, and we write them personalization hooks based off of that. Now, if this wasn't declared change and it was something else, obviously this hook would be entirely different. But the point being, without creating this label first, we wouldn't be able to scale it down and really get into this personalized approach based on the company's news and their funding signals and stuff like that. So then finally, after we've written the hooks, we come down to writing the DMs, and we take all of the above input, we add my voice, which is stored as context, and some previous examples of what good looks like. We inject them all into the DM writer, whose sole purpose is to write me DMs. And then we get the output of 1, 2, and 3. So each step's output becomes the next step's input. And you can see here how that forms the system's memory. Another benefit of this is that when something breaks, you know exactly where it broke. So if, for instance, the classification breaks, you know to go and check agent number 3, instead of trying to find an entire massive log within one agent where this thing might have gone wrong. And this brings us swiftly on to step 3, which is organizing your context. You need to make sure you have the right info at the exact right time. Each step only needs to see what it needs to see and nothing else. So you need to separate the rules from the live data, things that never change, like your ICP, your voice, your constraints. Those aren't going to change. But the live data, these are things that change per run, and this could be the profile and the research. These are the variables. Then different context for different steps. So the scrape step doesn't need voice rules at all. We need to keep that out of there. The write DM step doesn't need scraping instructions because they only need to do the thing that they need to do in their step. And less is more. Like we spoke about in the beginning, you're not going to dump 1,000 files on an intern's desk and say, figure it out. Don't dump a 50-page PDF into a system and expect it to just do stuff. It's going to get lost within the noise. So you don't want to take that approach. If we look at my system, this is what I did for my context files. I have my ICP definition. So this lives in knowledge ICP. And the target here is 80 to 1,500 employees, Series A or profitable, buyers, COO, VP of Ops, BizOps, and their pains are tool chaos, failed pilots. Now, obviously it's way more in depth. This is just an example for this slide. But then we would also have voice rules that live in knowledge. And we have the tone, be direct, peer-to-peer, no corporate fluff, banned words, stuff like that. And then the golden example, which is my examples of what good looks like and what bad looks like. And you can see what each step sees over here. So the scraping step only sees the LinkedIn URL. The research only sees the company name and domain. Classification only profile and ICP definitions, and the right DMs only the analysis, the voice, and the examples. And it's really important to do this because, again, you don't want something doing everything, like we discussed in step 6. So then next up, you need to create your prompts, and you need to understand that you have one job per prompt. So each AI call has a single clear responsibility. And there are tons of frameworks that you can use and best practices and things like that. But for the most part, a lot of people just use the role, task, context, constraints, and format. So every prompt follows the structure. Who are you? What's your job? What do you know? What are the rules? And what should a good output look like? And it's super important to put your examples in the context, not in the format. They're the reference material. They show what good looks like. So you include them in the context alongside your ICP and your voice rules and stuff like that. Format only defines the structure of your output. For me, I put all of my stuff in JSON format, so it's easier for the machine to read and I don't have to do all that stuff later. It can also be thrown into any AI that I want to, and it understands it immediately rather than just having a wall of human readable text. So for me, in format, I would put my output format as JSON. And then finally, you can use variables. Don't hard code the context. So for instance, if I want to inject my voice rules or my ICP and stuff like that, I just have the variable in my system. I don't write it out every single time or copy and paste these massive walls of text because I can just keep them in one place and my AI agent will chuck it in when it needs it. So if we look down in my example, this is a very basic prompt. It's not something I would use, but it's just to show you the categorization of how we would do it. So the role is you're an outbound sales expert writing LinkedIn DMs. Task, write a 3M DM sequence. Then the context variables. So here you can see I just use these variable placements. And this is an example for you to show you which one goes in where. So lead analysis would have the archetype, the pain points, and the hooks. The ICP context, who we target and why, stuff like that. Then I would have my constraints, DM1 under 3M characters, so on and so forth. And then my output format over here. Whereas in this case, it would be JSON format. And then step 5, we need to assemble the workflow. And this is wiring it all together after we've put everything on our canvas to understand what needs to happen where. So you have the steps, the context, and the prompts. Now you need to connect them into a running system. So step 1's output becomes step 2's input. Save the state as JSON so you can inspect what each step received and produced. And again, I always use JSON just because it's far simpler for a machine to read. And you can also understand it yourself because it's human readable. So inject the context at runtime. Each step loads its context files, the ICP, the voice, and the examples, and combines them with the live state to build the final prompt. I'll show you how to do this very soon. Then you need to decide where the data lives, and this is really important. So any results that you have, do we need to store them? And if we do, how do we store them? You could keep it in a database like Postgres or Supabase. If you're using the agentic workflow that I use, it will create something locally for you, probably in Postgres. But Supabase also has a really good free tier, so you can use that as an option for storage. You can use spreadsheets like Google Sheets, or you can use something more advanced like Airtable, which a lot of people do. The point is that you're going to need a place to store these temporary files or even permanent files so that your system knows where to grab things from and grab the information from to build the next step and continue whatever it needs to do. So you need to define your schema. What fields are you going to have in here? What types of data? What sources are going to be in there? And you would plan all of that out. And then you need to ensure that you have human checkpoints. For me, I will never send something to a stranger without reading it first. I don't trust AI that much. No matter how good my system is, it's not going to send a single thing without me reviewing it. So you need to think about what works for you. Some people are okay with just automating email outreach and stuff like that. So you need to understand what works for you. If something has a massive blast radius, as in it could cause critical damage to your brand, your reputation, or even you definitely want to have a human gate in there. So my example of wiring this all together, the orchestrator runs each step and passes state forward. So scrape, the input is the LinkedIn URL, the output is the profile.json, and that is saved to a temporary folder. Then the research thing runs. It takes the input from the previous step, which is the profile company name and the profile domain, and it outputs my research.json, which is also saved to temp. And you can see it carries on like that, but then we start to add the knowledge and the ICP.md, and that again goes into a temp folder and a temp folder. And finally, it will go into a spreadsheet. I review it in the spreadsheet, then I click approve. Once it's approved, it sends everything out to HeyReach, and then HeyReach goes and does the thing that it needs to do. So we could go over the implementation decisions that I made, but realistically, I think it's quite clear at this point, and definitely for you, you're going to want to be making your own decisions. For instance, think about it from this perspective. If you have this lead gen system identical to mine, and you're sending out leads, do you want a front end with a database and a thing that you can click around and see people before you do it? Most of the time, you really just want the leads. So a lot of people will build these super base backends, and it's something I used to do as well, thinking that you actually need this stuff in order to get the job done, but you don't. And Google Sheets works amazingly because everyone has it, it's free. So it's repeatable and you can use it as often as you want, most of your clients, and they understand exactly how to use it. So Google Sheets is really good for something like this. So the TLDR is make sure that you understand the schema that you need for your product. And if you're unsure of that, you can just ask AI, tell it what you're building and say, how do you think we should store this? What do you think the user flow should be? And we're going to get into a practical example of this very soon. And then finally, onto our last and most important step, which is testing and iterating, and debugging systematically would be a better word. So when something breaks, make sure you're pulling the right lever. You need to isolate the step. Because we have now broken down our process step by step, it's a lot easier for us to do that. So which step produced the bad output? And we can check that. Check the JSON at each stage. You don't need to guess anymore. Because you have these outputs being done in step 1, step 2, step 3, you can check the previous output and think, oh, okay, that's where something went wrong. Check the context. Was the right information available? Why did this thing go wrong? Print what the model actually saw so that you can see what's going on. A lot of the time it's something like missing data, or you put in the wrong variable and stuff like that. It didn't pick it up properly, in which case you just go back, fix that, rerun it. And then a really good way of looking at this is to start with your instructions, then go on to the examples that you output. Were they really as good as you thought they were? Then have a look at your workflow, and finally look at the model that you're using. So the model should be the last thing that we're trying to change, because realistically, if you're using GPT 5.1 or 5.2, that's a really good model. So it should definitely be able to give you the output that you need. So if it is failing, take a look at the other things first before you say, oh, we need a better model, we need to pay for Pro and stuff like that, because you probably don't. And then finally, you need to document what you learned, because even if it's not just you, someone else might use your system in the long run if you've sold it to them. So building the documentation up front gives them a troubleshooting guide of what to look at and how to approach a problem when it appears in their environment. So if we look at a practical example that I had, the bug was the DM said, I noticed you're using AI to transform operations. And the problem here is that the lead never mentioned AI. This was an obvious hallucination. So the investigation, we isolate the step, the generate DM step. Then we check the context. Research JSON had no AI mentions. Then we find the issue, prompt missing constraint about verified claims. And this actually happened to me because I forgot to put in my constraint. So it looked at this and it thought, okay, I could make this better by talking about these AI claims because it aligns perfectly with something downstream. But that's not what we wanted. So I added some constraints to the prompt. The truth rule, never claim they use AI unless the research data explicitly says so. If unsure, use softer framing, like if you're exploring AI, instead of since you're using AI. So something simple like that fixed a massive problem that I was having in my lead gen. And then finally, this is not part of the steps, but this is something that you need to understand for the entire picture. When you're building things for yourself or clients, those are two very different things. For me, when something goes wrong, I don't really care. I don't care if something breaks, I can fix it, I'm quite technical, I can do what needs to be done. But if you are selling something and you have not baked guardrails into it, it can be catastrophic for you and your business, and for the client's business, in which case it's even worse for you. So you really need to understand how to set your guardrails properly. Think of it like this. If this step goes wrong, if it fails or hallucinates, what's the worst thing that can happen? Now, if in a low blast radius, wrong JSON format, it's just going to retry the step. But if you have a high blast radius, you could send an offensive DM to someone and you could lose a customer forever. Or even worse, your reputation is nuked and your whole business is screwed. So high risk actions need that human gate. That's how I view any scenario that I have in any business. But then you need to look at things like least privilege. So each step can only do the one thing that it needs to do. The scraper can't write to a CRM. The DM writer can't send messages automatically, stuff like that. Each step should only be allowed to do what it needs to do in order to get the job done. Think of it like in a business. If you go into a company, you don't give all of your employees admin rights to do whatever the hell they want. Your agent needs to have the exact same thing. If you're giving API access, give it read access, not write access, ever. Imagine it went and posted a video or deleted your channel. You don't want those sorts of things happening. So least privilege is really important when you're dealing with this. And then human gates, as we've already discussed. And then you need to audit everything. And a lot of people don't do this, and barely anyone talks about this on YouTube for some reason, but you need to be logging your environment. So apart from having logs in our agentic workflow stored in a folder, you could also use tools like Helicone, which provide observability for your entire infrastructure and give you the benefits of costs and things like that, so you can actually help plan how much you're going to sell the system for a lot better. More importantly, you're actually going to have a system that shows you why this thing went wrong and where it went wrong, because without logs, you can't possibly troubleshoot anything. an agent shouldn't just do stuff. It should propose solutions for you that you can then approve, and then you can finally automate when you realize that there is little to no risk. Cool, so you made it to the TLDR, which we're going to go over now, and then we're going to get straight into the build with my tool. So context engineering is defining the task in the first step. What does good look like? Step 2 is mapping that process, break it into tiny steps. Input becomes the output for the next step. Step 3, organize your context, the rules versus the live data, the right info for the right step. You're only giving each step the exact amount of context that it needs in order to do the job. Step 4 is creating your prompts using the framework that you choose. Step 5 is assembling all of this, chaining it. Think of your N8N canvas, chaining each step after one another. Or if we're using an agentic workflow, to obviously do that for you with Python scripts. And then step 6 is to test and iterate. And this is arguably the most important thing. You want to eval, go over and over again until this thing gives you the exact output that you want every single time. And there are lots of tools that you can use to help you with this. So like I mentioned, Helicone, you can also use Langfuse. And this is to see what your environment is actually doing. You can use Prometheus, which is how you systematically refine each of your prompts. And it will also help you with your context engineering, especially for the part where you put the exact pieces for each of the process that you need, just the right amount of information, because obviously tokens cost money too. And then finally, your own JSON logs are going to be super important, because the AI can use to analyze to find out where things are going wrong or how things can be made better. And if I wanted to think about how to approach anything I was building, I would pick one thing that I do repeatedly. I would write down 3 perfect examples of that, and then I would just work backwards to get that thing done. This is how I got here. This is what I did. And then I would chunk it using this exact 6-step process here. Cool. So this is the builder that I put together, and it's based off of the entire slide deck that we went through previously, because you obviously need the practical enablement to understand what we did. Now, I'm not going to go through this entire thing because that would make the video way too long. And this is pretty self-explanatory, but I'm going to give you a high-level overview. So the first thing we need to do is talk about what we're building. Name your AI agent or app and describe what it does. Be specific about the inputs and the outputs. Remember, specific is what makes an amazing system. So the system name, let's just call it My Lead Gen System. A 1-sentence description. Describe what it does in 1 sentence. Include the input and the output. Takes a LinkedIn URL and produces a research personalized 3DM sequence ready for outreach. Cool, that's pretty straightforward. The input is the LinkedIn profile URL, the custom email, or the product description. And the output, what does this system produce? Personalized DM sequence, blog post. Let's just write something in here, blog posts. And the input is LinkedIn URL. I'm just putting random stuff in here because I want to show you what the output looks like. Takes a LinkedIn URL. Then we go on to the next step where we talk about the definition of good. So quality example number 1. What is the example? High converting email sequence. So email sequence. The example, blah, 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 blah. Why is this excellent? List the specific qualities that make this good. This is super important because it helps you understand your own brain. Like, okay, cool, why is this good? And it's because we didn't use jargon. It's because we spoke to them like a friend. It's because we spoke to them professionally. Whatever it is that makes your thing excellent would go in here. Then you have quality example number 2. And you want to have at least 2 at a minimum, maybe add 3. You can add more if you want. This thing just has a plus button. And then you can add your constraints if you want to as well. Then we go on to the process where we're breaking down the step-by-step process. Remember, we reverse engineer it. What does each step look like? What happens at the step name, the input and the output. So what this step needs in order to get its thing done, and what this thing is going to produce for the next step. Step 2, the step name, what happens in this step, same thing over and over again. And you do this over and over until you've mapped out your entire process. You can also bake in your human checkpoints. So after which steps should a human verify that it works? You would put that in here and the reason why you want the human in there. Then we go into the context, and this is where we're gathering context requirements. So you list all the information your system needs, organized by the type, the process, the domain, the policy. Is it external information that it needs? Stuff like that. So think about the domain context here. Knowledge the AI needs. If we're talking about reaching out to people, it's going to need my ICP, my voice guidelines, my frameworks, things like that. That's the domain context that I would chuck in here. Any background info about my company would also be useful. When we come down to policy context, these are going to be the rules and constraints, like the character limits, the banned words, the rules that it needs when it's doing the work that it's doing. And then any external resources. So what is this system going to need access to? The OpenAI API, Perplexity, Google Sheets, Slack. However your system is going to be built, we need to give context of the external resources that it would be using. And you could also bake in any databases that it might use here, stuff like that. And then finally, on this section, safety and privacy, which again is super important. So what personal data can or cannot be stored as output? Also take into consideration the models that you use. That data is going to traverse their system. So if you're building something for a client, you want to be writing things down here so they get a clear picture of what is happening with their data. If you have email addresses that are being read or email data that is being read, that is a massive red flag for a lot of companies. So you would put that kind of stuff in here so both you and them understand it. And then your output safety rules. So what should never appear in AI-generated outputs? Never output scraped email addresses, never claim facts without citation, stuff like that. Then you want to bake in some hallucination prevention. How do you prevent an AI from making things up? All facts must include the source URL. Mark claims as verified or inferred. That's something I've got in my system. I take the citations, I get it to use the citations. If there is no citation, then it uses inferred context and it says, yes, I made this up based on all signs pointing to that as opposed to it being an actual fact. Stuff like that. And then data retention. How long are you going to be keeping data for if you use a temp folder? How long does data stay in a database? Where does the database live? What country rules are there? Is there GDPR? Stuff like that. You need to think about all of these things in your system. Now, you don't really need to, but I would. And a lot of people don't think about this stuff. They just build something, they grab their money and they leave. But I promise you that stuff comes back. In this industry, it always comes back. I've been consulting for 10 years on 3 continents, and I always meet people at giant Fortune 500 and 100 companies that I've worked with historically. Even when I went down to some mid-market companies, I'm always working with those people because the networks are always limited in tech. So you've got to think about that. Then we have our prompts, which is self-explanatory at this point. So what's the prompt name, the role, the task, the context variables that would go in there. You don't need to use variables. Again, you can obviously fill in the context manually if you wanted to. My system just uses variables. The constraints that you want and the output form that you're going to use. You can add as many prompts as you want. Then we need to test everything. So how is your testing methodology going to go? For me, I want to test each prompt independently before assembling the full workflow. And I would probably do that. I would just chuck it into GPT Playground and see how it pans out. But then when I really want to get into the nitty-gritty of things, I'll use something like Prometheus, which I'll cover in another video. And I'll leave it in the description below if I haven't done that already. And then finally, you want to do an overall quality assessment. And that would be doing things like evals and retry loops, seeing what happens when the system fails, making sure you're getting the expected output every single time the system runs. I'm not going to cover evals in this video because it would just carry on forever, but I will create another video on that. The point being is that after you've run this like 50 times to 100 times, what remaining issues do you have? Is there anything that still needs improvement? At this point, hopefully it should be close to 0, but sometimes there are always things left over. Some things can't be fixed. And then finally, you need to package your system because obviously at this point, we want to be selling things to our clients. So you come down here and you look at the orchestrator. What is the name of our main orchestrator? In this case, it's researchlead.py. If you're using N8N, this would obviously be the main agent within your N8N workflow. What does it do? How does it coordinate all of the steps, stuff like that? Who are the workers or the components? We would list all of that stuff in here. What is the data storage? Again, you would put in the databases that we use and where everything ends up. And we might also map our variables here so everything is in the place that it needs to be and everyone can understand all the variables and what they do. So if it's like my voice is a variable, you would write down what your voice looks like, and then you would tell the AI where you've stored it and when to use it and things like that. And then finally, you can export everything that you work through here. So this is stored locally in the HTML file. It's got its own local storage. So you can take this wherever you go. It's really portable, but it will also store all of this stuff for you. And then you can just export it as an MD file. And the power with doing that is once you've gone through this, you can then just throw the MD file into your agent workflow and it can build your entire system for you. Because now you have given it the fullest possible context that any system needs in order to get its thing done. But there's even one more step that we can take. Let's say you really wanted to build a system, you had an idea of what you wanted to do, but you had no idea how to approach context engineering despite having all of this. So what I would do in that case is I would export a blank canvas. So literally kind of like what we've done here. Everything would be blank, but it is still a templatized format that the AI can understand. So you could just take this blank export, chuck it into an AI and say, I want to build this system. I have no idea how to go about doing it, but I have this context engineering worksheet. Fill it out step by step, ensure accuracy, and build me the system. And it would go ahead and do it. So you can see why this is powerful, because even if you don't know how to do it, then you have something that can do it for you and we can just throw it into AI. So I hope this video was helpful. I really tried to demystify something that people think is really complex, But this is the most vital thing you will ever do when you are building any system out there, or even talking to humans, because if you don't give humans enough context, they're not going to know what to do. So grab this thing for free in the description below. Check out some of the videos on the screen now. They're definitely going to help you on your journey, and leave some comments below. It helps the channel grow. I'll see you guys in the next video.